Hello everyone. This is our fourth lecture and today's topic is integrating factor. So first let's understand what is the application of integrating factor. Actually, or why we need integrating factor. Actually, in my last lecture I have told you that if the equation is not exact equation, then we cannot solve the problem. So if it is not exact, then we have to convert the non-exact equation to exact equation. Okay, and how we can convert this non-exact equation to exact equation? Using the integrating factor. Okay, so we have to know what is integrating factor or how we can convert this non-exact equation to exact equation. Let's understand using an example. Okay, suppose I have an equation x dy minus y dx, this is equals to 0. This is of the form m dx plus n dy equals to 0, yes or no? If I take the minus common, so this will be y dx minus x dy equals to 0. That means this is m dx plus n dy form. Okay, here m equals to minus y and n equals to x. What was the definition of exact equation? The definition of, okay, first check, is this equation exact? Obviously not. Here m equals to minus 1, m equals to minus y and n equals to x. So what will be del m del y? Minus 1 and del n del x 1. So obviously this equation is not exact equation, and according to the definition of exact equation, that we need a function u, so that deriving the function u, you will get the left hand side of the equation. Okay, and we have discussed this definition using the example that x dy plus y dx equals to 0, and this is the derivative of xy. Yes or no? See, if we get this function xy, or if we get a function u, so that du equals to m dx plus n dy, then you can say that this equation m dx plus n dy equals to 0 is exact equation. Yes. Now obviously this is not exact equation, and we have to convert this equation into exact equation. Okay, let's multiply this equation by or let's divide this equation by x square. So x dy minus y dx divided by x square, this is equals to 0. Yes. Now can you tell me the left hand side is the derivative of which function? Yes, obviously du of y by x. If you derive the function y by x, this will be the derivative x dy minus y dx divided by x square. Yes or no? So this is equals to 0. That means you are getting a function y by x. If you derive this function, you will get the left hand side of this equation. That means now this equation is exact equation and this is our non-exact equation, and you have multiplied 1 by x square. You have multiplied 1 by x square to convert this non-exact equation to exact equation. Clear? And this is your integrating factor. Short form is IF. So what is integrating factor? Integrating factor is a multiplying factor. And what is the use of integrating factor? We can convert non-exact equation to exact equation. Clear? So let's write the definition of integrating factor. So a function, let's say mu, function of x and y, is said to be an integrating factor or in short form you can write IF. Okay, so a function mu xy is said to be an integrating factor of the equation m dx plus n dy equals to 0 if there exists a function u is a function of x and y such that actually what I am doing, I am multiplying the integrating factor with the equation, then you are getting the derivative, yes or no, such that mu into m dx plus n dy, this is equals to d of u. Okay, this is the condition. So after multiplying the integrating factor mu, this equation becomes an exact equation. Okay, now easily you can solve this equation. But the problem is you cannot easily find out this multiplying factor or this integrating factor. This is not so easy. Okay, so to find out the integrating factor, you have total 6 rules. 6 rules in your syllabus. Okay, and you will learn 5 rules in this chapter and 1 rule in our second chapter. Clear? So let's understand rule number 1. Rule number 1. Okay, before starting these rules, let me tell you that this integrating factor, this is not unique. If integrating factor exists, then it must be infinitely many. Okay, but it is necessary that the integrating factor must satisfy the condition. What is the condition? The condition is the non-exact equation will be converted to exact equation. Or you can say after multiplying the integrating factor, the condition that del m del y equals to del n del x, that will satisfy this condition after multiplying the integrating factor. Okay, so let's understand rule number 1. Okay, we will learn together rule number 1 and rule number 2 because these two rules are similar. Okay, so first, suppose you have the equation m dx plus n dy equals to 0. Okay, this is your equation, and obviously this is non-exact equation. That means del m del y is not equals to del n del x. Okay, so you have the equation m dx plus n dy equals to 0, and this is non-exact equation. So now you need the integrating factor. So rule number 1. Rule number 1 is you have to find out the difference del m del y minus del n del x. Okay, you have to find out the difference del m del y minus del n del x and divide it by n. Okay, and divide it by n. Now if this result is a function of x only, okay, now if this result is a function of x only, okay, I am writing function of x only. Clear? Then e to the power integration fx dx, this will be your integrating factor. Clear? Okay, you have to remember this formula. Actually you are calculating del m del y, you are calculating del n del x. Now difference del m del y minus del n del x. Now you have to divide this difference by n. Okay, and the result, if the result is function of x only, then e to the power integration fx dx, that will be integrating factor. Okay, now rule number 2, this is almost same. In this case you have to find out the difference del n del x minus del m del y. Okay, now divide this difference by m. Okay, now if this result is a function of y only, g of y, that means let's say I am taking the function g of y, this is function of y only, then e to the power integration g of y dy, that will be your integrating factor. Okay, this is very confusing. If you don't practice these formulas, then you will forget this. Okay, so what is the short trick to remember this formula? Dekho. So first, when you are subtracting del m del y and del n del x, del m del y and del n del x. Okay, just this is short trick. There is no mathematical logic here. What is the first function? M. Yes or no? First variable is m. When the first variable is m, you have to divide by the opposite. Opposite means you have to divide by n. Okay, now what will be the result? Actually, to check the exactness, what we do, that del m del y and del n del x, that means there is a relation between n and x. So obviously the result will be function of x. Okay, this is not any mathematical logic, just to remember the formula. Okay, same logic you have to, when you are subtracting del n del x minus del m del y. Okay, here the first function is n, so obviously you have to divide by m, and the relation is del m del y, that means there is a relation between m and y, so the result will be function of y. Okay, so in this case the integrating factor will be e to the power fx dx. In this case, e to the power integration g of y dy. Okay, this is the short trick. If the first function is part is m, then you have to divide by n. If the first part is n, you have to divide by m. Relation between n and x, so the result will be function of x. Relation between m and y, so the result will be function of y. This is the short trick. Okay, let's understand using example. Okay, now you will ask me that sir, how I can understand that I have to apply rule number 1 or rule number 2. Actually there is no fixed rule. Okay, you have to simplify the difference del m del y minus del n del x, and then you can guess that rule number 1 or rule number 2 applicable. Okay, let's understand. Question: solve x cube plus x y to the power 4 dx plus 2y cube dy, this is equals to 0. So first check this equation is exact or not. Solution: here m is equals to x cube plus x y to the power 4 and n is equals to 2y cube. So what is del m del y? Del m del y equals to 4x y cube, and what is del n del x? Del n del x equals to 0, because here there is no function of x. So obviously del m del y is not equals to del n del x. Okay, this imply non-exact equation. Okay, now how you can identify that rule number 1 or rule number 2 will be applicable? Actually, if I subtract del m del y from del n del x, or del m del y and del n del x, then the result will be 4xy cube. Okay, 4xy cube, the result will be 4xy cube. If you divide by m, so obviously the result will be not a function of x or function of y only. That will be not a single variable result. If you divide by n, then y will be cancelled out and the result will be function of x only. Yes, that means you have to divide by n. Okay, so that means you have to apply the rule number 1. So 1 by n del m del y minus del n del x. Okay, let's check the result. This result will be function of x only, so let's check. So 1 by n, that means 1 by 2y cube into del m del y. Del m del y means this one, 4xy cube. minus del and del x, that means 0. So this is equals to, now y cube cancelled out, so 2, so this is 2x. 2x is the result. So what will be integrating factor? If equals to e to the power integration fx dx, this is formula. So this is equals to e to the power integration 2x dx, and this is equals to e to the power, this will be x square. There will be no integrating constant, only the result. Okay, so e to the power x square, this is your integrating factor. Clear? Now the process is, you have to multiply this integrating factor with the equation, then the equation will be converted to exact equation. Then you can apply the formula, solution of exact equation formula, which I have discussed in lecture number 5.3. Okay, so let's multiply this integrating factor with the equation. So multiplying the given equation by integrating factor. Okay, so this will be e to the power x square into, equation was x cube plus x y to the power 4 dx plus e to the power x square into 2y cube dy, this is equals to 0. Correct? Yes. So now after multiplying this, now this equation is exact equation. Yes or no? This equation is exact equation. Now you have to find out the solution. Okay, how to solve this equation? Okay, you can apply the formula, that integration m dx, this formula. Okay, let's apply this formula, integration m dx plus integration terms of n free from x dy, this is equals to 0. Okay, so or integration m dx, so this will be x cube e to the power x square plus x y to the power 4 e to the power x square into dx plus terms of n free from x. Here this is in multiplication form now, so we cannot separate this x, so this will be integration 0 dy, this is equals to c, integrating constant. Okay, this is equals to c. Okay, now we have to integrate this part. So integration, okay, this is x cube. Okay, let me write again, so that x cube e to the power x square plus x y to the power 4 e to the power x square dx. Okay, and integration of 0 dy, actually integration of 0 dy is c, any arbitrary constant, and again you have one arbitrary constant on right hand side. Actually in you can adjust this arbitrary constant, and I am writing only one arbitrary constant c. Okay, there is no restriction on arbitrary constant, so this is equals to c. So or now how to solve this integration? Okay, let's separate this. This is x cube e to the power x square dx plus integration x y to the power 4 e to the power x square dx, this is equals to c. Okay, now if I multiply by half, okay, if I multiply by half, so this will be half into 2x cube e to the power x square dx. Yes, okay, plus, and this part integration with respect to x, that means y to the power 4, this is constant, will be treated as constant, so y to the power 4 is out, and let's multiply by 2, so y to the power 4 by 2, so this will be 2x e to the power x square dx. This is equals to c. Now if I take x square equals to z, x square equals to z, so this will be 2x dx. This is equals to dz. Yes or no? 2x dx equals to dz. So you can write half into integration 2x cube, that means x square into e to the power x square into 2x dx. Is it correct? Yes or no? Just I have separated it. This is 2x cube, I have written x square into 2x. Okay, plus y to the power 4 divided by 2 integration, again you can write this is e to the power x square into 2x dx. This is equals to c, or half integration. What is x square? X square means z, so this will be z e to the power z into dz, because 2x dx equals to dz, plus y to the power 4 by 2 e to the power x square, that means e to the power z, 2x dx means dz. This is equals to c, or half. Okay, what is the formula of integration z e to the power z? You know, integration x e to the power x dx, this is equals to x minus 1 into e to the power x. This is the formula. Okay, integration x e to the power x dx equals to x minus 1 e to the power x dx. Or you can calculate this using the integration by parts rule. Okay, so this will be integration z minus 1 into e to the power z, okay, plus y to the power 4 by 2. This will be integration of e to the power z is e to the power z equals to c. Okay, now put z equals to x square, so or half into x square minus 1 e to the power x square plus y to the power 4 divided by 2 e to the power x square. This is equals to c. Okay, if I simplify this, so let's take e to the power x square common. Okay, so e to the power x square is common, and you can take half common, na? You can take half common, and 2 will be multiplied to c, and that means this is again arbitrary constant, so I can adjust the value half. Okay, so let's ignore the value half. So you are getting x square minus 1 e to the power x square plus y to the power 4 e to the power x square. This is equals to 2c, and 2c equals to, let's say, c dash. That means the arbitrary constant. Okay, so or if I take common e to the power x square common, so this is equals to x square minus 1 plus y to the power 4. This is equals to arbitrary constant c test, and this is the solution, is the required solution. Okay, so in this way you can solve the problem of integrating factor. Okay, let's solve another problem using another rule. So next problem, question. Solve x to the power 4 plus y to the power 4 dx minus x y cube dy. This is equals to 0. Okay, so here m is equals to x to the power 4 plus y to the power 4, and n is equals to minus x y cube. So what will be del m del y? Del m del y equals to 4y cube, and what is del n del x? Minus y cube. So obviously del m del y is not equals to del n del x. That means this is non-exact equation. Okay, this is non-exact equation. Now you have to find out the integrating factor. Okay, if I subtract del m del y and del n del x, so you are getting the result 3y cube. Okay, 3y cube, and if you divide by n, then y cube will be cancelled and x will be the result. Oh, that means this is again the rule number 1. Okay, let's try. So del m 1 by n del m del y minus del n del x, this is equals to, okay, so 1 by n, that means minus 1 by x y cube into del m del y, that means 4y cube, and minus del n del x, that means minus minus plus, so this will be y cube. That means you are getting, this is minus 5y cube divided by x y cube is cancelled, minus 5 by x. This is your result. So integrating factor equals to e to the power integration minus 5 by x dx. That means this is equals to e to the power minus 5 log x. Okay, and e to the power minus 5 log x, that means this is equals to e to the power log of x to the power minus 5. Yes or no? E to the power log of x to the power minus 5 and e to the power logs, that means both will be cancelled, so the answer will be x to the power minus 5, and this is equals to 1 by x to the power 5. This is your integrating factor, 1 by x to the power 5. Okay, now multiply this integrating factor with the given equation. So multiplying if with the given equation, so what you are getting, the equation is x to the power 4 plus y to the power 4. This will be x to the power 4 plus y to the power 4 divided by x to the power 5 dx minus x y cube divided by x to the power 5 dy. This is equals to 0. Or if I divide by x to the power 5, so this will be 1 by x plus y to the power 4 by x to the power 5 dx minus x will be cancelled, so this will be y cube divided by x to the power 4 dy. This is equals to 0. Okay, now this is of the form m dx plus n dy equals to 0. Now you can apply the formula of exact equation. Okay, so integration m dx plus integration terms of n free from x dy, this is equals to c, integrating constant c. So or integration m dx, m means 1 by x plus y to the power 4 by x to the power 5, 1 by x plus y to the power 4 by x to the power 5 dx plus integration terms of n free from x, but here you have x na, so you cannot neglect this x, so this part will be 0, so integration 0 dy, this is equals to c. Or now just you have to integrate this part, integration 1 by x dx, that means log of x plus y to the power 4 by x to the power 5, and integration is with respect to x, so this will be y to the power 4 x to the power minus 5 plus 1, that means minus 4 divided by minus 4, this is equals to c. So you are getting log of x minus y to the power 4 divided by 4x to the power 4, this is equals to c, and this is your answer. Okay, this is the answer. Okay, now practice all the questions from your textbook, from your question bank, and from previous years. And if you have any doubt, then you can ask me on WhatsApp group. Thank you so much.